today we are talking about tangents. A tangent line intersects a circle exactly at one point, called the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius. Drawn to the point of the tangency. Okay, so I need to, if it's perpendicular, it should make a right angle right here on this triangle. On numbers 1 and 2, I need to decide if the line AB is tangent to circle P. The way I'm going to do this is by using the Pythagorean theorem. If A squared plus B squared equals C squared, then it means it is a right triangle. So, I am going to, C is always my hypotenuse, and then A and B don't matter. So I'm going to plug that into the Pythagorean theorem. I'm going to have 8 squared plus 15 squared equals 17 squared. So then I just need to figure out these. 8 squared is 64. I don't know 15 squared, so I'm going to go to decimals. No, not that decimals. So 15 squared is 225. And then I need to figure out what 17 squared is. Which gets me 289. Okay, so what I want to do is I want to go ahead and add my numbers on the right side to see if they are going to add to 289. So I can go back to Desmos. I have 64 plus 225. So I have 289. Because this is true, it is tangent. So my answer here is yes. So I'm going to do the same thing on number 2, but notice this 5 isn't this whole line across. It's only this outside piece. I have this part that's also 11. So the whole length of this line right here is 16. And I got the 11 because it's a radius from the center to the edge. So then I want to, again, use the Pythagorean theorem to see if this makes a right triangle. The 16 is going to be my C, and then A and B don't matter. So I'm going to have 14 squared plus 11 squared equals 16 squared. So first thing I want to do is I want to figure out what 14 squared is, which is 196. Then I need to figure out what 11 squared is. I remember this one is 121. And then I need to figure out 16 squared. Which is 256. Okay, then I want to add my numbers on the right side to see if this is going to add up to 256. I'm going to go back to Desmos. I have 196 plus 121, which gives me 317. $317 does not equal 256, so this answer is going to be no. Okay, so on numbers 3 and 4, or 3 through 9, it tells me that it's tangent to the circle. It wants me to find the measure of x. So, on number 3, x is my hypotenuse, so this is going to be my c. And then my sides don't matter for a and b. So I'm going to plug into the Pythagorean theorem. I'm going to have 7 squared plus 19 squared equals c squared. Then I want to figure this out. 7 squared is 49. I'm going to go back to Desmos to see what 19 squared is. 361. Then I want to add 49 and 361, which gets me 410. Then to get c alone, I want to take the square root of both sides. So I can go to Desmos for this. Which gets me, I'm going to round to 1 decimal place, so 20.2. So same thing on number 4. This one, the 7 is only on the outside, so I know this is 11 because of the radius. So this whole length is going to be 18. So when I would plug into my Pythagorean theorem, this is going to be my c value, and then a and b don't matter. So I'm going to have 11 squared plus x squared equals 18 squared. So 11 squared is 121. Oops, I didn't want to write 18 squared. I wanted to find 18 squared. Which is 324. Then I want to get all of my numbers over to the same side, so I'm going to subtract 121 on both sides. This gets me x squared on the left. So I want to do 324 minus 121, which gets me 203. Then I want to square root both sides. Which is going to get me 14.2. Questions here? So number 5, similar idea. The x is only the part outside the circle, so this 10 is the part inside the circle. The whole length for this segment right here is x plus 10, which is going to be my c value when I plug into the Pythagorean theorem. And then a and b don't matter. So I'm going to have 24 squared equals 10 squared plus, what? Not equals. This should be the plus, this should be the equals, and then x plus 10 squared. Okay, so first I want to figure out what 24 squared is, which is 576. 10 squared is 100. And then this one right here is the same thing as saying x plus 10 times x plus 10. So I have two binomials that are being multiplied by each other. I have x times x, which is going to give me x squared. X times 10, which gives me 10x. 10 times x gives me 10x. 10 times 10 gives me 100. So on the left side, I want to combine my terms. 576 plus 100 is 676. On the right side, I have just 1x squared, but I have 10x and 10x, which are going to add to 20x, plus 100. Then I want to go ahead and subtract 676 from both sides. Gets me 0 equals x squared plus 20x. And this is going to give me negative 576. looking for two numbers that multiplied in negative 576 that add up to 20. I'm just going to tell you these. It's going to be positive 36 and negative 16. Then I want to take each of those and set them equal to 0. On this first one, I would subtract 36 from both sides, which gets me x equals negative 36. On the second one, I add 16 to both sides, which gets me x equals 16. Because x is a measurement, it has to be positive. So this one doesn't work. Only 16 is my answer for number 5. Questions there? Okay, so number 6, it gives me this triangle. On this picture, this is where my right angle is. So it tells me 11 is the length of this radius, which means this radius is also 11. This whole length, however, is going to be 22. 25 is my C value, and then A and B don't matter. So I'm going to have 22 squared plus x squared equals 25 squared. Then I want to go ahead and square each of those numbers. So I'm going to go 2 decimals to figure out what 22 squared is. 484. And then $25 squared is 625. Then I want to go ahead and subtract 484 on both sides. This gets me x squared, and then 625 minus 484 is 141. Then I want to go ahead and square root both sides. Which gets me 11 point, and then this is going to 9 round to a 9 because of the 7. So my answer here is 11.9. number 7, this is kind of the same. My right angle is right here. I have 3.5 as one of the lengths of half of this line because of the radius, so this is also going to be 3.5. That means the total length here is 7. So on this picture, this is my hypotenuse, and then A and B don't matter. So I'm going to have 7 squared plus 6.4 squared equals C squared. So 7 squared is 49. I don't know 6.4 squared, so I'm going to go to Johnstone's. Which gets me, this is going to round to 41. Okay, then I'm going to add 49 and 41 together. 90. No, it's right. Okay, then I want to go ahead and square root both sides. Which gets me 9.5. Questions there? So I'm going to do the same thing on number 8, except this one, my radius makes it 2x. I have 2 of those. My hypotenuse is the 25, and then A and B. Don't matter which ones I make those. So I'm going to have 7 squared plus 2x squared equals 25 squared. So then 7 squared is 49. With the 2x in parentheses, I want to give the exponent to both the 2 and the x. So 2 squared is 4, and then x squared just stays x squared. And this is going to equal 25 squared, which earlier we figured out was 625. Then I want to go ahead and subtract 49 on both sides. So this gets me 4x squared equals whatever 625 minus 49 is. 576. Then I want to go ahead and divide both sides by 4. Which gets me 144. Then I can square root both sides. Does anyone know the square root of 144? 12. Questions here on number 8. moving on to the back, we're actually going to skip number 9. So I have more tangent line properties. If I have two segments from the same external point, so point B, and they're both tangent to the circle, then they are congruent. So whenever I have something that kind of looks like an ice cream cone sideways, it means the two side lengths are congruent. If I have it with a triangle, then if the circle is inscribed in a triangle, all the sides are tangent. So that means that these two are going to be congruent, these two are going to be congruent, and then these two are congruent. So on number 10, it wants me to find the value of x. What I want to do here is I want to take my two line segments, since they're going to be congruent. I'm going to set those equal to each other, because congruent means the same. So first I want to move all of my x's over to the same side. I'm going to subtract 5x on both sides. This gets me 23 on the left. 8 minus 5 is 3. And then I still have my minus 19 at the end. Then I want to go ahead and add 19 to both sides, which I can't do mental math in my head today. Gets us 42. Then I can go ahead and divide both sides by 3. Which gets me 14. Questions on number 10? So I want to do the same thing on number 11. I'm going to set these two expressions equal to each other. Then I want to get all of my variables over to the same side. So I'm going to subtract 8x, which gets me 6x minus 13 equals 5. Then I want to go ahead and add 13 to both sides, which gets me 6x equals 18. Then I can divide both sides by 6, and I get x equals 3. Okay. So on number 12, it's the same idea, but then it wants me to find the length of SV at the end. SV is this line right here. So we're going to start off the same. I'm going to set my two expressions the same because I still need to figure out what x is in order to find the length of ST. So then I want to start off by subtracting 4x on both sides. This gets me 6x minus 41 equals 7. Then I want to add 41 to both sides. Gets me 6x equals 48. Then I want to divide both sides by 6. Gets me x equals 8. I'm not done. I need to plug back into one of these triangles. Which one do you want me to plug into? The 10x or the 4x? Okay. So I'm going to redraw this triangle. I'm plugging in here. And then this is going to be what I'm solving for in the end. So 4 times 8 is... Actually, I can take this whole expression into decimals. So that gets me 39. Then I want to use the Pythagorean theorem. This is going to be C, and then A and B don't matter. So I'm going to have 17 squared plus 39 squared equals x squared. So I want to figure out what 17 squared is. Just 289. Then I got to figure out 39 squared, which is 1521. Still equals x squared. So then I want to add those two numbers together. Which gets me 1810. Then to get x alone, I want to square root both sides. Which gets me 42.5. Questions on number 12? Okay. Number 13 wants me to find the perimeter, and it gives me this triangle. So remember that the two sides that touch are always congruent. This is going to be 11 because this was 11. This one's going to be 16, and this one's going to be 9.5. So then I just want to go ahead and add up all of my side lengths. So I'm going to have 11 plus 16, 11 plus 11 plus 16 plus 16 plus 9.5 plus 9.5. Then I just need to go ahead and type this into decimals. Which gets me 73. Questions here? On this one, it's a little bit tricky. I'm missing this side length and this side length. So I know that this one has to be the same as the 27.1. So this is 27.1. I need to take the 52.5 and subtract 27.1 to figure out this one right here. Which gets me 25.4. Which makes this outside one 25.4. Then I know this one is 23, which makes this one over here 23. I want to subtract 23 to figure out the other side. Which gets me 14.5. Which makes this outside one 14.5. So what I'm going to be adding together are this 37.5, this 23, this 25.4, this 52.5, the 27.1, and the 14.5. All of the other numbers are just used to help me find the missing links. So 37.5 plus 14.5 plus 27.1 plus 52.5 plus 25.4 plus 23 . So then I just want to go ahead and go into Desmos and type those in. Which gets me 180. Questions here.